ever get that feeling?
Okay.
Like there's just way more to the universe than we can see.
Oh, I know exactly what you mean.
Yeah, well, you're right. There is.
Yeah.
Today we're tackling dark matter.
Definitely a cosmic puzzle.
Big time. We're going deep on what it is, how scientists are trying to find it, and, why it even matters to you.
Right.
You guys sent in some seriously cool research, so let's dive in, huh? We're talking 85% of the universe is matter, but invisible.
It's wild, right? The thing is, we've got solid evidence this stuff exists, even though, well, we can't directly see it.
Okay, so no giant missing matter signpost out in space.
Ha! Not quite. But the signs are there, you just gotta know where to look.
All right, I'm all ears.
Take how galaxies rotate. They're spinning way faster than they should based on what we see.
Huh.
It's like a merry-go-round with only a couple kids on it, but it's going crazy fast. You'd think there's got to be some unseen weight making it spin like that.
Yeah, that makes sense. So it's the speed that's the giveaway.
Exactly. The visible stuff just isn't enough to explain it, and then there's gravitational lensing.
Ooh, that's a cool one.
Right. Picture light traveling through space, and it runs into a massive object, like a whole galaxy cluster.
Okay, got it.
Well, that massive object, it warps the fabric of space-time around it.
Like a bowling ball on a trampoline.
Perfect analogy. And that warp, it acts like a lens, bending the light passing by.
Trippy.
Totally. So when we look at galaxies behind those massive objects, their images get all distorted, magnified.
Like a cosmic funhouse mirror.
You got it. But here's the thing. The amount of bending we see, way more than the visible matter can account for.
So the lens is stronger than it should be.
Exactly. It's like there's this invisible mass, dark matter, adding to that gravitational pull.
Wow, so it's not just what we see, but how the light itself is acting. Mind-blowing.
It really is. That's why this search for dark matter is so exciting. It's like a giant cosmic detective story.
With scientists as the detectives.
You got it. And they're using every trick in the book to track down this mysterious stuff.
Well, from the research you sent, it seems like there are a few prime suspects in this cosmic case, right?
Absolutely. Each one totally unique, like fuzzy dark matter. Despite the name, it's not cuddly at all.
Okay.
Think of it like a school of fish all swimming together, creating these wave-like patterns.
I can picture that.
That's kind of how fuzzy dark matter is thought to behave, rippling through galaxies on a huge scale.
So not individual particles, but waves of dark matter.
That's the idea. And these waves, they could explain why galaxy cores aren't as packed as traditional models suggest.
Interesting.
But there's a catch. Recent studies using that lensing effect, they've put limits on how much dark matter can be this fuzzy kind.
Oh, so how much are we talking?
No more than 10% of the total dark matter out there.
So fuzzy dark matter may be part of the puzzle, but not the whole picture. What about these WIMPs I keep hearing about?
Ah, WIMPs. Weakly interacting massive particles. They've been the front runners in this dark matter race for ages.
Okay. And they're thought to be way heavier than those fuzzy particles.
So how do these weak interactions come into play?
Imagine trying to catch a neutrino. Tiny, practically massless particle as it zips through a light year of lead.
Yikes. Sounds impossible.
That's basically the challenge with detecting WIMPs. They interact with regular matter, but it's insanely rare.
So like finding a needle in a cosmic haystack, where the needle is practically invisible.
You nailed it. So scientists are building these crazy sensitive detectors, deep underground, shielded from everything.
Hoping to catch a WIMP bumping into an atom?
Bingo!
I read about that LUX Zeppelin experiment. Seriously impressive what lengths they're going to.
It is. But after decades of searching, still no definite proof of WIMPs. It's leading to some serious head-scratching.
Huh, the mystery deepens. Are there any other potential suspects we should be looking at?
There's another candidate that's really out there. Dark matter might not be particles at all.
Okay, I'm listening.
It could be primordial black holes. Whoa, black holes. That's a curveball. So instead of these exotic particles, we're talking tiny black holes all over the universe.
That's the idea. These primordial black holes, they would form super early, like right after the Big Bang.
Okay, but how could we even detect those? Especially if they're tiny, billions of years old. Talk about finding a needle in a haystack.
Right. But that's what's so cool at this search. We're actually getting the tools to maybe actually find them.
Really? Like what?
One way is using those gravitational wave observatories, LIGO and Virgo.
Right, I've heard of those.
They're designed to detect ripples in space-time, from massive objects colliding. And they might pick up signals from these ancient black holes merging.
So we could hear these black holes colliding. across space. That's incredible.
It is. And then there's this method called microlensing.
Microlensing.
Yeah, so if a primordial black hole passes in front of a distant star, its gravity bends the light, makes the star look brighter for a bit.
Ah, so we're looking for these little blips of brightness.
Exactly. And by monitoring millions of stars, astronomers can look for those signs, black holes passing by.
Clever. It sounds like scientists are casting a pretty wide net. But what if dark matter isn't any of this? Something we haven't even thought of.
Totally possible. That's part of what makes science so fun, right? Challenging what we think we know.
Okay, so what else is out there?
Well, some theories try to explain those dark matter effects without needing dark matter at all.
Wait, really? How does that even work?
One idea is called modified Newtonian dynamics, or MOND. It suggests that gravity itself might act differently at huge scales.
So instead of adding invisible matter, we're changing the laws of physics. That's a big leap.
It is. It's like, imagine a rubber sheet representing space-time. Instead of a bowling ball making a dent, like in Einstein's theory, MOND says it makes a wave.
A wave.
Yeah, that extends way further out, affecting things at greater distances.
So that extra pull could explain why galaxies rotate like they do. No dark matter need.
Exactly. Then there's emergent gravity, even wilder. Gravity isn't a fundamental force. It comes from, the properties of space-time itself.
Okay, now we're getting pretty deep. But it's fascinating to consider all these options. It seems like this search for dark matter is pushing the limits of what we know.
Absolutely. It is. But before we go full-on theoretical, let's bring it back down to Earth.
Back to reality.
You might be thinking, why should I care about this invisible stuff billions of light years away?
Honestly, yeah, that thought did cross my mind. Why does dark matter matter to, someone like me?
Great question. And the answer, it's more profound than you might think. This isn't just about solving a puzzle. It's about understanding, the core of the universe and our place in it.
Wow, okay, I see what you mean.
Cracking the code of dark matter, it'd have huge ripple effects. Rewrite textbooks on physics, cosmology, even philosophy.
It could change everything.
Right, how galaxies form, how the universe evolved, maybe even give us clues about the Big Bang itself.
I'm starting to grasp the enormity of it all. But what's next for this research? What are scientists working on right now?
Well, one big one is, of course, still, what is dark matter made of?
Right, that's the million-dollar question.
It is. But another is, how does it interact with itself? Does it clump, form structures? We're just starting to figure that out.
So much we don't know.
Exactly. But that's what's so cool. Every answer just leads to more questions.
That's the beauty of science, right?
It is. And speaking of exploration, there's another side to this I find really interesting.
Oh,
the
wow.
practical side.
Wait, practical. So this isn't just theoretical physics, up in the clouds. There could be real-world uses.
Potentially.
Tell me more.
One idea is harnessing dark matter for energy. Think about it. A source of energy that's everywhere, practically infinite.
That would change everything.
Mm-hmm.
But how would we even harness something we can't see or touch?
$1 million question. But there are some wild ideas being tossed around.
Like what?
One concept is building detectors that capture the energy released when dark matter particles, annihilate each other.
Annihilate. Sounds intense.
It is. But remember, we're dealing with particles unlike anything we know.
True.
When certain types collide, they can totally annihilate, converting mass into pure energy. Eve MC saw it,
Right, Einstein's famous equation. But wouldn't those annihilation events be super rare? Space is huge, and dark matter seems pretty spread out.
Good point. The odds of a direct hit are tiny. But dark matter makes up a lot of the universe's mass.
Yeah, that's true.
So even a small fraction annihilating could release a ton of energy.
So the key is building detectors sensitive enough to catch those rare events.
You got it. And the tech is getting there. Detectors using supercooled materials, powerful magnets, trying to pick up those signals.
It's like science fiction. But let's say we do manage to harness this dark matter energy. What would that mean?
Huge implications. It could revolutionize energy. Clean, sustainable power for, practically forever. Powering cities, transportation, even space travel.
Incredible. But are there downsides? Risks to messing with dark matter? Unforeseen consequences, maybe?
That's something scientists are thinking about for sure. Gotta be careful.
Yeah, it's not something to take lightly.
One worry is manipulating dark matter could mess up the balance of the universe. It's key to how galaxies form and all that.
So we could, unravel the universe by accident.
Maybe not that dramatic. But we need to know what we're doing before we start playing with something so fundamental.
Right. It's a good reminder that for all our smarts, we still know so little.
Absolutely. But let's shift gears for a minute.
Okay, where to?
What about the philosophical side of dark matter?
Ooh, I like that. We were just talking about some pretty big what-ifs with actually using dark matter. But even if we never get to that point, just knowing it's there, shaping everything, it kind of makes you think, you know?
It really does. It changes how we see reality. Like,
Mm.
we're so used to what we can see and touch. But dark matter, it's a reminder that there's so much more out there, hidden stuff we're just starting to understand.
It's humbling, right? Like we're peeking behind the curtain of the universe a little bit,
Yeah.
but also super exciting. Where does this search go from here? What's next?
Well, a few areas are really heating up. One is those detectors, making them even more sensitive.
We talked about LUXZ plan, but there are others too, right?
Yeah. Like Pandex in China. Cutting-edge tech, trying to catch those tiny dark matter interactions.
What makes these new ones different? Just bigger and better.
Bigger, yeah, which helps. But the tech is also way more advanced. Pandex, for example, uses this huge tank of liquid xenon.
Bizon.
Yeah, super cooled. And if a dark matter particle hits one of those xenon atoms, it makes a tiny flash of light. The detector can see that.
Wow. Like setting a trap to catch a ghost.
Exactly.
Hmm.
And they're not just looking for the same old wimps anymore. Remember those heavy dark matter ideas?
Whimzillas and those supermassive black holes, yeah?
There are experiments now looking specifically for those. And using those gravitational waves, maybe we can hear those ancient black holes merging.
Like listening to the Big Bang echo. That's incredible.
And we're just getting started with gravitational wave astronomy. As the detectors get even better, who knows what we'll hear.
Amazing.
And while experiments are pushing the limits, the theorists are busy too, you know? Coming up with new ideas.
Always got to have the theory, folks, what they're working on.
One cool idea is self-interacting dark matter.
Self-interacting, like they're talking to each other.
Not quite. But interacting in ways we hadn't thought of before. Usually we assume they only interact through gravity, right?
Right.
But what if they also interact through something else? Some force we don't know about?
Interesting. How would that even work?
Well, instead of passing through each other like ghosts, they might bounce off each other, creating a kind of pressure.
Pressure.
Yeah, and that could change how dark matter behaves, especially in those big galaxy clusters.
They're like a whole new rule in the cosmic game.
Exactly.
Yeah.
He could explain why dark matter doesn't clump up as much as we thought it would.
Wild. Tiny changes in our understanding can have huge effects.
That's the universe for you. And the best part is, we can test these ideas. Scientists are looking for signs of this self-interaction, you know, when galaxies collide and how dark matter spreads out.
Like a giant puzzle, and we're slowly figuring it out.
Hmm.
You know, this has been a fascinating deep dive. But I gotta say, even with all this amazing stuff, I'm still left with a sense of awe. It's humbling, knowing we're surrounded by this invisible force shaping everything.
I know what you mean. It really puts things in perspective.
And it's inspiring, too.
Yeah.
What are some of the big takeaways you hope listeners walk away with?
Well, first, that there's still so much to discover. We've only scratched the surface. Second, that science is constantly evolving. What we know today might be completely different tomorrow.
That's exciting.
It is. And finally, I hope everyone listening feels a little bit of that awe and wonder that we feel. The universe is full of mysteries, and it's up to us to explore them.
Absolutely. Well, on that note, I think we've reached the end of our deep dive into the world of dark matter. It's been a fantastic journey.
Couldn't have said it better myself.
To all our listeners, thanks for joining us. Keep those questions coming, keep exploring, and never stop being curious about the universe and our place in it. Who knows what amazing discoveries are waiting just around the corner?